And Al, thanks Al for the time you are offering, and it's the end of the day. It was a raining day, so I'm sure it was not easy to come. I know Netherlands and the problems with the traffic, so I'm sure it was not easy to come to here. So, okay, I'm from Nuage Networks. We deliver software-defined networking solution for enterprises and cloud and service providers. And my intention is just to give you an overview of the solution and some details. I understood that this meetup was about security, so I put a couple of slides around security to line up a little bit up with what actually your interest was in. So maybe the first thing is let me introduce the company. So Nuage Networks, I mean, we are a spin-in from Alcatel-Lucent. Spin-in is probably a strange construct. So let's just clarify it a little bit. We are a dedicated group of people in Alcatel-Lucent that have the freedom to develop and to work on the best way of delivering a software-defined network. We present us as an independent entity. We have own Nuage Network business cards. But of course, if we need to execute, if we need to deliver, we are falling back on the engineering capabilities of Alcatel-Lucent all over the place. Okay, so we started as a quite small team. I think in the meantime we have extensively grown, and we have in nearly all European countries we have local people present, like here in the Netherlands, André. I'm sure he will help with whatever is needed around Nuage Networks. So our mission principally is making networking as consumable as compute. I mean, compute is these days very automized. It's easy, and we believe that that is not the case with networking, and that it should be the case with networking. And that's what we try to bring. The key points, it's all about abstraction, it's automation, that are the things that are important for us. So it's a policy-controlled, software-defined networking, actually driven by applications or business needs. So that are the key things around, the key points around that our solution is concentrated. So we make something abstract, something automated, not manual anymore, policy controlled and fully open. So my intention first was, okay, let's look to a couple of customer cases to understand a little bit where we are fitting with the technology and what we are doing. And when we started like 2 years ago, and we were walking around with a solution, with the first solution, because in reality, Nuage Networks, what we have created is what I would call a software-defined toolkit. A software-defined toolkit that allows us to look to the network, to the traditional network, and to see where we could bring value on that network with a software-defined networking way. And we have, based on that toolkit, we have created different products. We were coming out with the first product in April 2013, the Virtual Service Platform, and that addressed the data center networking area. We have looked further on, and we have seen that also other side of the network can actually benefit from the SDN view. And we have, in November last year, we brought out the Virtual Network Service solution addressing the WAN network. And it is perfectly possible and even very likely that we are going to come out with more solutions where we think it can bring value to the way we do networking. Okay, so that's very important. So when we started in April 2013 and we visited around and we were bringing our story to the market, to customers, I mean, maybe we were a little bit early, not everyone was really ready to understand what we were telling, or maybe we were not articulating it so well, who knows. But after a while, what we discovered is that a certain industry segment that was very interested in this kind of technology was the financial market. So, and actually we can understand why. And what I have done here is I have not made the slides myself, I just put the title on it. I have taken some customer slides. This slide is coming from Santander. Actually, Santander is a large banking group, very large banking group worldwide. And their IT organization is like autonomous, and it's called Product Bank. And it is delivering IT services to all their different banking divisions and business lines. I believe that the banking industry is very worried. The banking industry is very worried about the whole movement that we have on the internet and the online tools and customers that we have. So, and they are realizing that for them there is a big threat. There is a big threat because I don't know about all of you guys, but the last 2 years I haven't visited any bank offices anymore in whatever place. The only thing I do is just going online to my account and I do all my wire transfer, all my money, I treat everything from there. So from them that's a very big threat and they are very worried about that, and that's why they are looking to optimize and to change their current way of working. Okay? So that is their vision. If what are they doing, what are they trying to change? I took that slide from them. So what they are looking for is they are looking for a self-portal, an orchestration layer, where the finally end users can drive their own services on compute and on networking. And that would be capable of going by APIs to whatever kind of underlying systems. Okay? So they are looking for a global deployment, and that's quite common because in the meantime we visit more banks. So they would like to have, and most of the banks have done data center consolidation. They have a couple of data centers in every part of the world, but they would like to have transparency on networking between their infrastructure. Okay. So they are looking for global deployments in different regions and availability zones. They are looking for hybrid cloud, but are today building still our private cloud. And then the next phase is moving into public cloud, but he would like to have the same transparency and the capabilities of starting workloads up, whatever it is, on the same way in private and in public cloud, with the same security and policy environment. Okay. So they had the greenfield approach. They were not restricted by whatever kind of existing technology they had in a company, so they could take free choices. They are looking for commoditization on the servers, on the server side, where they are going for x86 compute, and they are looking for commoditization also on the networking infrastructure, where they are looking to broadband kind 3 and 2 switches. Okay, and they are looking for, of course, I mean, I explained. They are fully multi-tenant because there is one IT organization that is autonomous and is supporting all different banking. So they need to have a fully multi-tenant environment. So what is the stack that he actually selected and that he have built out? So that is a very high-level view of what they have, what they are creating or what they have created already. So, as I thought, they are going for commoditized hardware on networking or on server side. They will take a VM hypervisor on top for the hypervisor layer, and they are going for a Red Hat OpenStack environment. And in the Red Hat OpenStack, they integrate the software-defined storage and a software-defined compute. Okay. And then we have platforms as management, and you see Santander is from a Spanish country, so they are much stronger in the Spanish part of the world, in Latin America. So they have always redundant data center setup in different parts of the world, but they have transparent networking between. Whatever application could be started up in whatever kind of data center. Okay, so that was one of the first customers 2 years ago where we started to work together. And to be honest, we discovered what I was telling is we did the same with BVBA. And if you look to this slide, I mean, the case of BVBA have been presented in the Open Stack Summit in November 2014 in Paris, where Chema, the innovation director, was speaking about the deployment that you were doing at that moment in time. So what was the motivation there? The motivation was coming from the security teams that were requested to reinforce and to automate the security deployment around applications, the need to program network functionality, and of course they needed also to upgrade bandwidth between data, just like. So and we found that that was a good time also to introduce SDN as a technology. So their roadmap is first creating private clouds, then they are looking to bring in their company a more DevOps-oriented way of deploying applications. Then they would go to hybrid cloud and then bring higher value applications and cloud consolidation. So where were they so pleased also with the Nuage solution? So they were very pleased because we have a full multi-tenancy environment and we have templates. We deploy networking with templates. A template you can define very easily once and you can instantiate and re-instantiate as you need it on an automated way. We have the full API availability. We were integrated with OpenStack and we are still integrating with all new versions of OpenStack. We have a full distributed way of doing the networking, and we have a hypervisor agnostic solution. And I could go on like that, but that's not the intention. Also Barclays, you see, over the 2 years, what we have seen is that, of course, the financial industry was one of the fastest one to deploy this kind of technology. But I believe it has spread out into the market now also to other industry segments. So the intention of bringing that is picturing a little bit in which kind of environment we are. I mean, the environment is that this kind of companies are on a stress to deploy faster applications to the market and to do it more automated. So we could not do that on our own. We have created a partnership with an ecosystem around our product. We have then around cloud, because cloud in data center is a very important thing. OpenStack, we see in all these companies a movement to open source. So we follow that. We have done relations with the most cloud systems that are available into the market. We are working with traditional deployed security and service appliance that you find in these companies, because there is always a legacy. But of course, we are actively working with new challenging technology in each of this domain, like you have IV networks in distributed load balancing, or like you have GuardianCom in detecting security threats. And we have a solution that works and is integrated together. And of course we are flexible. I mean, what we are trying to bring is a software solution for automated, templated-based networking. So we are ready to work with whatever kind of hardware vendor and infrastructure. And we have set up agreements with Arista. We have agreements with HP. By the way, our solution, the Nuage Networks solution, is also OEM'd by HP. So HP, if you look to their cloud offering, they have OEM'd our solution, they call it distributed cloud network. The difference is that we like orange, as Netherlands we should like orange too, I believe, and that HP likes blue. Okay, so but that would be the GUI are nearly the same beside the colors. So that's a little bit to build up credibility, what we have done over the last 2 years, and of course having Alcatel-Lucent as mothership. We have, of course, also a lot of service providers and cloud service providers that are using and that are interested in and testing Nuage as a solution. Okay, so having told that, why can this traditional enterprise network, what is the issue with this network? I mean, why should now this change, or why is that we have created over years, we have created that very carefully. We are all very clever people. We have automated as much as we could do. We have very nice management systems. And still, apparently, it don't seem to do the job. So there is a need to have another way. And I try just to make a summary of a data center network, of an enterprise network where you have data center and we have branch offices. And you have a little bit of virtualization all over the places. And in the data center you have like layer 2 levels, and then you are going up to a layer 3 domain and all that. Actually you have a network, I would say, full of isolation. I mean, for your virtualization environment, you probably are giving out VLANs and IP addresses, and you are doing a spreadsheet management on your network side. I mean, that's probably not the best thing that you should do. But if you look and if you speak to people, what is happening today still in a lot of companies. So if you need to provision a new service, all these red points, I just put them a little bit as logic as possible, are points where you need to do configuration. Actually, from my point of view, what you are confronted with a network that is full configuration points, that's full of state. And that makes it so difficult and sloppy to provision. If a new application comes on board, the system people have that act very well together. They just start up a couple of VMs, they start to work, and then they look to the network people. And then things got slow, or the people of the network are always in the middle part. You don't like to be there. So that is something that is actually the issue with this network. And the problem with this is that the end user perception is changing. Cloud is there. Compute can be started very fast. So if you from your network side have not the same capabilities of doing your network instantiation at the same time, but maybe end users are just going outside the company and just go to public cloud and they can continue working. So the customer expectation is shifting. And it is not like it's going to become better in the future. Because where 2 years ago everyone was looking to infrastructure as a service, I mean the front runners today are already looking to platform as a service. I mean they are looking to containers, and it's not going to stay like one containers. Applications are going to consist of a multitude of containers that are going to work together, and they are going to scale in and they are going to scale out. So it's not going to be a constant environment. There is a lot of dynamism going to be in that network. So what you are actually looking for is a networking that allow you to create application bubbles, application segments, policy groups, application policy groups, whatever you like to call it, that can consist of different technologies, being bare metals. Maybe you still have some heavy database. In reality, they are still running on bare metal servers. A number of virtualized systems, VMs, and containers. And that all with the same policy and security environment around it. So that's where we are heading to. And that's what we as Nuage are also bringing. So what is the way to do? We have thought, we have looked to that network, we have said, okay, we are confronted with a network where we have a lot of dedicated systems, specialized systems, and where we need to do all this configuration. So what is a way of going away from that? What would be a way of creating a solution and do that differently? Now, if I look to the network that was coming up and to the problem, I mean, if I look years ago in the WAN space from the service providers, the moment that they were starting to offer IP VPNs, they had an issue. They were not doing that as good as requested by their customers. Because why? They were confronted with a WAN network full of devices where they needed to configure all different endpoints. They were actually confronted with a WAN network full of state information. So what has been done to go away from that? I mean, we have introduced a tunneling technology. And we have said, okay, we are going to solve the fact that we need to configure all these different boxes. We are just going to configure the entry points. So we are going to create service edge. And that was the MPLS edge router. And then from that device, we are just going to tunnel everything transparently over a network in the MPLS tunnels till the endpoint. So that made it possible to reduce the complexity of the network. So I think we can do perfectly the same into this network. What we would actually looking for is we would look to create an overlay network. Actually, we would like to separate the problems and to have it on two different levels. We would have what I would call an infrastructure level, where you actually, the only thing that you would do is like routing packets from left to right, as performant as you can do, but that you would not touch for whatever service configuration. And then you would like to have an overlay service network. An overlay service network that you start by preference as close as possible to the application. So, and that's also the view that we have. Only the tunneling is not, MPLS is for sure not the most optimized way of doing tunnels for this kind of network these days, because you need to set them up, you need to maintain them. Now what we are going to do is, for tunneling system, we are going to use VXLAN. We are going to take the layer 2 packets and we are going to encapsulate in a layer 3 packet, and that we are going to send over the network. By doing so, we have taken away the need to configure whatever box into the middle. And we have, if we start the service overlay network from the software side, we can easily program it. We can easily program it and change it and adapt it to whatever is needed into the future. So that's the vision we have. So what we would create is a separation between what I would call an infrastructure network, just to having the traffic of your packets as performant as possible and as stupid as possible. You would not change anything into that network, and you would take a service overlay network that you would run on top of it. And you would hide all complexity by just taking the packet and encapsulate it and have it on VXLAN tunnels over your network. I mean, you don't need to set up anything. I mean, the only thing, what would be your destination is your termination server or your termination hypervisor, where you would decapsulate the packet and bring it to the right container or VM or whatever endpoint you are going to have. So what is the way that we would do this? To be able of doing this, what we have created is what I would call an SDN toolset. An SDN toolset, in the view of SDN networking, we have a management plane, we have a control plane, and we have a forwarding plane. So what we have created is 3 different software components. We have what we call a virtual service director. Is the policy engine. You could compare it with the management plane. It's going to be software running on VMs, one or more, depend on the level of redundancy and the kind of configuration you are making. So management, the VSDN, the Virtual Service Director, that's where we are going to define the abstraction of the service that we need. That's where we are going to define network templates. That's where we are going to do the intelligent work. We define exactly what we are expecting, and we make it by the VSD available to whatever kind of orchestration or whatever kind of cloud management system that you are having in your place, ready for consumption. Okay. Then we have the VSC. The VSC is the control plane. That's the real SDN controller we are using. So what's the VSC? The VSC is a software running on a VM, deployed somewhere in the infrastructure, and also one or more, depending on the level you like to have. What is fundamentally different with our solution compared with other solutions onto the market is the fact that we have created from in the beginning what we call a federated SDN controller solution. We have not just looked to one data center, and we have created a solution that addresses that one data center. We know that in companies you don't have one data center. In reality, you have multiple data centers, and you like to have this transparency on your templating between the different data centers. So that's why we have from in the beginning federated or SDN controllers. So what we will do in the SDN controller, we will instantiate on an automated way the templates that you have defined into the VSD or the policy engine. Okay? And then we have a third software. We have the VRS, and the VRS is going to be the place where we are starting or overlaying. So it's going to be a software that we are installing on the hypervisors. Okay? So, and it's going to be OVS based, as in most hypervisors you have the OVS switch. We are going to use them, standard OVS switch, to make sure that we are independent of whatever kind of upgrade on hypervisor version that needs to happen. And we are going to put a program on top of it that is going to program in automatic way the overlay network. Okay? And that's the way, I mean, in my first part of my explanation, I'm just going to assume that the full world is virtual. I mean, that's not a reality, but it makes it easy to explain the concepts. And then later on, I will come down and I will say also the way that we integrate bare metals. So the VRS is going to give us also, because we have the VRS support for different hypervisors, the KVM, the Zen, the ASXI, Hyper-V in the future. It gives you also a consistent and the same parity for all different of hypervisors from a network point of view. So that's the tool set. That's the tool set. And with this tool set, we are going to create different solutions. And the first one that we announced in April 2013 onto the market is what we call the Virtual Service Platform. That's using these three components, bring them together as a product, optimize them for the use for that part of the network, bring some additional functionality that we need for that, and that's a solution that would be addressing the network virtualization and automatization of the data center network. The next product will be the VNS. So that's okay, the Virtual Service Platform, create virtual networks, because at the end that's what we need in the data center. Every service, every application that we are bringing up is like a different virtual layer 2 or layer 3 environment that we like to control. And that's what we are going to instantiate. Okay. I'm also going to address the virtual service network is the second one, but I'm going to stress the most on this one because the principles will be very similar, and in respect of time I only have 1 hour to explain, but I will address it very high level. So the virtual service platform, that's the way that things would work together. I have already explained that we have three different software components. Different software components, we are going to deploy them somewhere on VMs in the infrastructure. We are going to have the VSD, and the VSD is going to be the place where we define network templates. And we are going to define our network templates as abstract as possible. We are not going to put in like IP addresses, VLANs, because then you could not redeploy them on different environments. We like to create an abstraction. So you can redeploy and reinstantiate in different data centers all over the world. You don't need to repeat what you today need to do. If you do that from a network point of view, you export your templates. If people then like to start up new applications, they can go to an orchestration level, they can select different compute, and they can select the network template. The network template is abstract. If on the network side we need to change anything for whatever reason because the company compliance or requirements changed, we can perfectly change the template behind and changing it, and everyone that will instantiate and all templates that are already instantiated will actually automatically change without any intervention that you need to do. So by the effect of abstraction, you actually create your own freedom of taking care of your own business from a networking point of view. Okay, so we define the templates, we put the templates in the VSD, we have a REST API that allow to export the templates to whatever kind of orchestration or cloud management system. And actually, we are done. Now let's look to the way that we are going to deploy the applications. Actually, an application deployment means that at least you need to deploy some servers. So that means that you would start up some virtual servers somewhere on your infrastructure. So you would start up, you would have servers on your infrastructure. They would be the view that we have from the point of view of a VM, is that a VM is something that is going to, like your mobile phone. It's something that is going to appear on your network. You would not know where, you would not know when, but it will be automatically detected and it will receive automatically from a policy-driven way his network configuration, just as your mobile phones works today. So the VMs would start up somewhere on your infrastructure, and the VRSs or data plane software that is installed in the hypervisors would detect that a new server is becoming active and would actually request the configuration. He would request the configuration to the VSC, to the SDN controller. The SDN controller would forward the request to the VSD, the policy engine. The policy engine would make the relation between the server and the template. He will send the template down to the VSC, and in the VSC we will, in an automatic way, instantiate the template. We will see what are the different virtual networks that you need, what is the cost, what is the bitrate limitations, what are all different characteristics of that network template, and we will instantiate that into the SDN controller. And the SDN controller, the communication between the VSD and the VSC will be done on XMPP. So we will send that to the SDN controller. And then the SDN controller, once he has instantiated the network, he will send by OpenFlow, he will actually see the different VRSs as his line card of a router. And he will actually translate or program by OpenFlow the forwarding tables into the different servers. Key information that he needs to know, but only for the services that will be deployed on that server. So you don't send just like all information to, you do it on a very selective Okay, so that's the basic principle. So now, I mean, till now, I just have looked to like one data center. Isn't it? I just looked to a very small part of an infrastructure. You have like one VSD, you have one VSC, and you have a number of servers connected to it. The reality is you never have that. The reality is you always have like multiple cloud infrastructures. So what you need to have is you need to have a way of bringing over the service information of services that are defined in one data center or one cloud environment to another one. And what we are going to use for that is multi-protocol BGP. Multi-protocol BGP is the protocol that we are going to use to peer between the different VSCs, the different SDN controllers. So actually, whatever protocol we could create, it could have done, but everywhere where we needed to make a selection on a protocol, we always have taken the decision of going for something open. So we have OpenFlow. OpenFlow is a very high-performant way of programming forwarding tables, and it's very open and it's known. We have XMPP as message bus, and we have multi-protocol BGP as federation principle between the SDN controllers. Now, what do we need to exchange? Actually, the reality is, if you look to application environments, what it is, your template is going to be a number of virtual layer 2 and layer 3 networks. So we are going to exchange with multi-protocol BGP the IP and MAC addresses of all servers that are part of that template with another part of the infrastructure, so that they can actually talk to each other in the service offering. So let's just look to every part a little bit more in detail. So the VSD is a virtual machine-based environment where you do your definition of your templates, of your network constructs. We have also a full analytic, and we have a role-based way of accessing to the VSD. You have an infrastructure provider or a cloud service provider as user. You have different network designers, and you have the end users that can all, on their own level, define networking. So that's what I was saying. So if you look to the templating, because I think the templating of the network construction is quite important. So there are different ways that you make the templating. Maybe you have the people that are responsible for what I would call the infrastructure or the network design, the overall network design, and we give them a templating that is abstract, but that is oriented networking. And then you could have like application designers. Application designers, they don't like to know what is an IP address. Their job in life is to develop applications, so we give them what we call an application design template, where the only thing that they need to do is select, okay, I need to have a multi-tier application. I need, for instance, to have an e-commerce. An e-commerce is going to consist of like web servers, it's going to consist of like a business logic and a database, so you can perfectly define upfront the communications and the ports that need to speak between this different level and define that as an application. And then the application designer just need to select, okay, I need to have a web application, and by consequence all the network parameters that are behind it would be automatically programmed, speaking to a business logic and speaking to a database. On the policy design, we have what we call the same line as you have like people taking care of the infrastructure provider to the application people. So you have what we call sandwich ACLs. You have the capabilities. You are responsible for the network in the company, so you can define the top and the bottom list. You know, if you are looking to the application people, you know that you don't like to have telnet because it's not secure. You know that everyone needs to have SSHs to go into the different devices. So you can define that as a top priority list policy. And at the end you can say, okay, I like to drop everything. And then you have the people of applications that can bring in their ACLs that are needed for the application level. So the VSC is actually also a virtual machine, is the SDN controller, and it's based on the routing, the IP routing stack that has been used for multiple years in Alcatel-Lucent. The only thing that we have done is we have taken the IP control plane from our devices and we have virtualized it, we have installed it on a VM, and we run the IP control stack on a VM. So that gives you the certitude that what we have as IP control stack is actually field proven, and he will do the peering and the auto discovering, and he will also do the slicing of the network. The network virtualization will be done into the SDN control. Okay, the virtual routing and switching element, that's the forwarding plane. It's, as I told already, OV switch based. You have a hypervisor, you have the OV switch. We keep the OV switch in the kernel space. We are just going to put a process on top of the OV switch to program the flows and to program the flows of the service network that we are going to put in overlay over it. So I try to bring it all together from a point of view of federation. So guys, do I lose you? Do you have a good question? Tell me. So let's go over it again. Let's go over it together. So what we have is we have 3 software components. We are going to deploy a 3 software component on the infrastructure. We are going to have a VSD. Suppose we are going to create a new e-commerce. We are going to have web devices. We are going to have business logic. We are going to have databases. So we need to program that from the web you can have, from the external world, you can have access on port 80 to your web servers. From your web servers, you need to go to the business logic on a number of ports, defined depending with the application. And then from that, you need to go on another number of ports to your databases. And your 2 databases need to speak to each other to create redundancy. So in reality, you can perfectly take an Oracle white paper. You can look perfectly the kind that this kind of application needs to be instantiated onto the network. So you are going to take that and you are going to define that as a template. Once you have defined that, you are going to put it into the VSD. Okay? And from that VSD, you can then export it. You export it to whatever kind of orchestration or cloud management system. Once you have defined it, the next thing that will happen is that somewhere on your infrastructure, you will start up these web servers. You will, as VMs, as virtual machines, you will start up some VMs that are going to run the business logic. You are going to have some databases. So there are going to be VMs that appear onto the infrastructure. They are going to be detected by the VRS in the hypervisor. The hypervisor is going to detect that a web server appears. So the VRS will not know what to do with that. he needs to receive on a policy-driven way the configuration for that device, the network configuration. So the VRS will detect that here, apparently, there is a subnet, a layer 2 subnet, where you have red web servers. So this device needs to receive its network configuration. So we have defined a template with abstraction. We have said, okay, this web servers will be on a red subnet. Okay, when the device starts up, we will detect that that web server is part of subnet red. So we will take that information and we will say, look, I have a new virtual machine starting up on my infrastructure that actually is part of subnet red. What network configuration do I need to give this device, and with whom is he capable of speaking? So the VRS will detect, okay, a new red VM is starting up. I don't know what I need to do with them, so I'm going to ask my SDN controller. My SDN controller is responsible to program all flows of all other devices in my virtual service network that I'm supposed to speak with. I'm the first one, so that template is not yet existing. And I have not yet any other party to speak to. But I will be detected. I will inform my SDN controller, look, I'm new here, I don't know what I need to do, I don't know to who I need to speak. The SDN controller will take that information and will say, actually, I don't know it either. But let's ask the policy engine. It's going to forward the request, it's going to say, look, apparently I have here a VM part of the abstract service red. Okay. He is going to make the relation between that defined abstraction that you defined here. He's saying, the abstract service red is actually corresponding with a layer 2 segment where you are going to have multiple web servers. So he will say, okay, so that information he will send back to the SDN controller. The SDN controller will say, okay, red is actually a layer 2 network, of just plain layer 2 network, where you are going to have like 3 or 4 web servers on. So I need to instantiate a layer 2 network. He is going to instantiate into the SDN controller, he is going to instantiate a layer 2 network. And then he is going to say, so I need to program the characteristics of the network parameters of that VM. Okay, in the beginning, he is on his own. There is not so much to program, he is just to protect by ICLs on which kind of port he can speak. But there is no one else to speak with. But an application you never start on his own, another VM is there also. They work with 2. So the VM will also start up on some other part of the infrastructure. The same process is going to happen. Also there, the VM is going to be detected. The VRS, the forwarding plane, is going to say, look, the VM is going to be started up very soon on my infrastructure. So can you tell me what we need to do with that? That will go to the SDN controller. That will go to the template. That will be related with your abstraction that you have exported. He will take that abstraction. He will say, look, that VM apparently is part of the same abstract layer 2 network on my infrastructure. And actually, he needs to speak. He is actually on the same layer 2 network as that other kind of VM that already exists. So the SDN controller is going to program here the IP and MAC address of that device. And he is going to program the IP and MAC address of both devices to each other. So he is going to program the layer 2 and the layer 3 forwarding tables. Okay? And then he is going to create a virtual network completely transparent on VXLAN by giving it as next hop the hypervisor, the virtual network over the infrastructure. Is that making sense?
Most important thing is fully automated.
Yeah.
So once you've created a template, you can simply take the template, duplicate it, make changes, and you get a next template or next policy.
So that was on the same kind of data center. That's quite easy. However, notice that because we have the VRS available for different kind of hypervisor technology, what we have now done in a fully automated is created virtual networks between different type of virtual cloud environments. I mean, you could have like a cloud setup on EXXI, you could have one on KVM, you could have one on Zen, on Hyper-V. If you like to do that today, what you typically need to do is you need to extend the layer 2 networks between these different cloud environments. So today you don't need to do that anymore, because once the packet is going to leave the hypervisor, it's going to be encapsulated in a layer 3 packet. And it's going to go transparently over your network. So you don't need to worry about layer 2 extensions anymore. Okay? So that allows you, so now if you have a second data center, suppose you have a second data center, but the thing stays completely the same. I mean, you would start up an additional VM, part of the same layer 2 network. So again, it will be detected. Probably in this data center you have another SDN controller, or you could have the same SDN controller. He would forward it, he would go to the template, and he will receive, even if he is not in Amsterdam but in Rotterdam, and even if there are plenty of whatever kind of networks between it, I mean, he will be programmed with the MAC and the IP addresses of the other VMs, part of the same service network. And then when it comes out, it will be encapsulated in layer 3, and you will create a fully transparent layer 2 network between different data centers in different locations. Okay. Most likely, you will have an additional SDN controller if you are in a data center in another location. So then you will go to that SDN controller. And what will happen is these both SDN controllers, they will detect that you have in both data centers a service that spans, that is also deployed in another data center, because by multi-protocol BGP, they will exchange between other the service identified and the IP and MAC addresses of the devices of the same service in one data center with another data center. Okay? So the advantage that we bring is, okay, we deliver transparently template-based networking across multiple kind of hypervisors, across multiple clouds, because this template we can easily export to OpenStack, to VMware, to CloudStack, and from there you can instantiate it. If we export here by REST API service network, RED, instead of in VMware, in your traditional ESXi environment, selecting a VLAN, you would actually select abstraction RED. And you could do the same in OpenStack. And by consequence, you will create networks that are transparent between different cloud environments. Okay, we can do the same with hardware devices. I mean, with hardware devices, what we actually are going to do is we are going to do a translation. The traditional bare metal devices or the traditional servers, they are connected today on VLANs. So if we like to bring the same VLANs or servers or switches into the same automation, what we need to do is program the relation between the VLAN and the VXI, the VXLAN identifier that will be used to create a transparent network. So that's what we were addressing. So what we have seen is now we have looked to the SDN into the virtualized environment. the VSD, the VSC, the VRS for whatever kind of hypervisor technology. So if we like to integrate traditional legacy servers, what we need is something that is going to translate between the legacy VLAN world and the VXLAN world. That will make a translation between a VLAN ID and a VXLAN ID that correspond with the virtual network that you have. So and there we have a number of solutions available. Of course, you always can use a software gateway solution. What you have is a software that you start up and that will take VLANs and translate it in VXLANs. And that's very good for low bandwidth, for flexibility, but of course, it is not very high performant. And it can only connect the limit of bare metal servers. The alternative is work with OpenFlow programmable switches. I mean, if you have switches that are OpenFlow programmable, you can perfectly, from our solution, program existing Arista, HP, Dell, Cumulus switches, and say, okay, port 3 of that switch, VLAN 5, now needs to be connected to a VXLAN ID corresponding with your service. We have our own device that can integrate, and we have additional capabilities because we speak multi-protocol BGP. We can also interface with existing data center PE routers on BGP level, and by consequence taking IP routing information from the data center PE and integrate into the same automation. Okay. And as we deploy the service networks completely transparent on a layer 3, we also create the capabilities of making interaction between existing private cloud and hybrid cloud. So we create true capabilities of having services deployed on non-virtual assets, on virtual assets, in a private cloud environment, and also into a public cloud environment. So, as it was about security, I thought let me just take some slides on the security of the solution. So I made up some slides that say, okay, if we look to security, where are we bringing security into the data center or in this cloud environment? But first of all, because we instantiate multiple layer 3s that are completely separated from each other, we create a full secure multi-tenancy. Okay? So that allows you to use your existing data center not only for one business line but for multiple business lines, completely transparent with overlapping IP address. That's all possible. So we create a full secure multi-tenant solution for public and private cloud. Additional, I mean, the service networks that we are defining, they don't need to follow network definitions. They can perfectly, based on what we call micro-segmentation, we can perfectly label a number of VMs and group them together in a policy group and say this policy group can only speak between them, but he cannot speak with whatever kind of other virtual device outside of this policy. So when we deliver, as we use OpenFlow to program the OV switches, we have a full programmable up to layer 4 of the flows. And we support policy-based routing, so we can decide if your traffic need to have a higher security inspection. We can, driven on a policy-based routing way, we can say for this kind of traffic with this kind of ACL, you don't need to follow the default route, but you need to be routed to a security device somewhere in the infrastructure. Okay. So, because if you define your policies, and you export your abstractions, if you change the policy behind the abstraction, automatically it will be replicated all over your infrastructure. And we work together with people that try to find security threats into the data center on the cloud environment, and we have defined an API that can be used by them to move workloads that are threatened from security in a quarantine zone directly. So the multi-tenancy or this, so you have the physical network. The physical network will be split up in different domains, different separated layer 3 environments, and in the different separated layer 3 environments you can have different zones consisting out of different policy group, number of devices groups together, and control the way that they communicate to each other. Okay. So we have secure multi-tenancy, you have a flexible segmentation just based on node grouping, independent of IP and on VLANs. So the micro-segmentation, what we are going to do is we are just going to label devices with a certain color, and we are going to say, look, they can speak to each other on that and that way, but they cannot speak outside the environment. And we have layer 4 ACLs, reflective layer 4 ACLs to control that. Okay. And if needed, for whatever reason, you need to have a more detailed inspection of your security, we use policy-based routing in the solution to redirect flows going to a network firewall gateway somewhere in the infrastructure.
Currently we're working with Palo Alto to integrate them fully.
Yeah.
At the request of Palo Alto.
So we are doing the logging of all ACLs that we have in the service overlay, and we are taking the first packets and send them into the VSD that has a vuln analytic database. And also we log there the flows, the GITs and the non-GITs, and we can actually do port mirroring for certain flows and direct them to a special location when needed. So what I was telling before, the compliance enforcement, I mean, you have a certain number of security rules in the company, compliance that you need to be, and actually the most financial institutions have them today and offer the banking crisis more and more. So you define your templates. Because your users are going to instantiate the templates to deploy the service, you have always 100% certitude that you are in line with the templates that you have defined. And if for whatever reason the template needs to change, the moment that you change, it's going to replicate it down automatically to all deployed services that will use that template into the future or have used that template already before. Okay, and that's the way that we work together with Cardiac Core that is going to speak after me. For instance, what we have defined on the VSD is we have defined an API that allow whatever kind of security threat systems to tell us that we need to move some workload from an infected zone into an isolated zone. So that's the data center networking. I mean, now we can apply the same kind of principles to the WAN. I mean, we have an SDN toolkit. We are going to use the same SDN toolkit to bring value into the branch or you do-it-yourself VPN network into the WAN network. Because also there, if you look to that space, there is a lot of dependencies, and people would like to have a solution that can be also automated in the deploying of the network configurations. So actually we would do the same thing. We would use the same what we have as we used into the data center. I mean, if you look to the CPE that is existing into the one space today, you have a physical device that has property hardware, has their own forwarding plane, a control plane, and a management plane. So let's make an SDN solution. So we will move to commodity hardware, supporting virtualization, using the same thing as we do in the data center. Do programming of the vSwitch for the forwarding of the flows. Move it to the VSC that actually would instruct the one service that you would like to deploy, and use the VSD. And so what you would have now is a commodized CPE that can be used. That's the solution we would have. We have the energy as software, like we have the VRS, we have now the energy, a physical device or a virtual device controlled by the VSC and the VSD. Creating flexibility in deployment. I mean, you can run it on your own, bring your own hardware. You can run it as an operating system on the device. You can run it as a VM image on a device, or you can have physical hardware that we are delivering with a solution. You could have it over an existing private network or over the internet network, and you could have also performance-based routing between them, depending on what would be the most optimized environment. Of course, if you use it in one space, what was not an issue in the data center is security. I mean, in the one space, we would secure all traffic between it. So what are the Nuage differentiations? I mean, we have a no-lock-in solution. We can virtualize whatever data center. I mean, we have a federation solution, so not just like islands. We can deploy it across all data center assets, hardware, and virtual and containers, and in whatever kind of mixed environment. So I think that was it. The right SDN solution, bringing abstraction, automation, policy control, and an open solution. Okay, any questions? Please.
How does it compare to, say, Open Contrail?
The Open Contrail is a solution that is also trying to deliver similar functionality. We are capable, I think that Open Contrail was only capable of doing layer 3 networking and not capable of doing layer 2 networking.
Open Contrail is not fully independent of underlying hardware.
Yeah. Also,
so we're more open in that fashion. Open Contrail is a community software. It looks like it's for free, but if you get a service on it, you pay $1,000 per node per year. So if you have 2 nodes per instance, and you got like 180 nodes, you're paying $360,000 a year. Ka-ching.
And it takes you 4 weeks to install.
That's another thing. The other thing is that, like I said, it's community software, so it needs a lot of PS to get it installed. We work with basic templates, and you learn it easily. We can do these deployments in 10 days.
Mark, thank you very much.
Yep.
We can have also discussions.